This video is going to focus on sketching the graph of an equation. And before we get into that, we're going to look at how can we determine whether a point is a solution to a given equation. So to do that, we have the following example: y equals the square root of 5 minus x. And we want to determine, is this point a solution? Well, all we have to do is plug in the values. Of course, the first coordinate is the x, the second is the y. So in place of y, we substitute 2 equals the square root of 5 minus 1. So does 2 equal the square root of 5 minus 1? And 5 minus 1 is 4. So we take the square root of 4, and we certainly end up with 2 equals 2. So the answer is yes, this is a solution because we end up with a true statement. Now, is the other point a solution? Well, again, we have our x and our y, so we plug in for y. We have 0 equals the square root of 5 minus our x, which is 4. So we have then the square root of 5 minus 4 is 1. The square root of 1 is 1. Well, in this case, 0 does not equal 1, so no, this is not a solution to the equation. And really what we're finding here, the solution to the equation, all of these points that are solutions are going to make up our graph. So that's what we want to look at next. It says complete the table and graph the equation. Y equals 2x squared plus 3. So if we complete the given table, they tell us that we have x is equal to 0, 1, 2, -1, and -2. So all we have to do is substitute in the x value to find y. So we could simply say y equals 2 times 0 squared plus 3, and we end up with 0 squared is 0 times 2 is 0. 0 plus 3 is 3. So therefore our y value is equal to 3. And then we would continue the same pattern. We would then move to 1, and we would get y equals 2 times 1 squared plus 3, and we get y equals 1 squared is 1 times 2 is 2. 2 plus 3 is equal to 5. And we would continue so on. And again, if we plug in the 2, we're going to get 2 squared, which is 4. And then 4 times 2 is 8. 8 plus 3 is 11. Now, if you notice here, this table had positive x values, and it's always good if you're looking at coming up with a sketch of your graph to always pick some negative values. So the table has a -1 and a -2. Now, be careful. When we plug in the -1, we're going to get 2 times -1 squared plus 3. And make sure you put that -1 in parentheses because you're not squaring only the 1, but we're squaring the -1. So therefore, when you square the -1, it's going to be a positive 1 because -1 times -1 is 1, and then 2 times 1 is 2, and 2 plus 3 is equal to 5. And then the same thing is going to happen for the -2. We're going to get y equals 2 times -2 squared plus 3. So again, when you square this -2, that's going to be 4 times 2 is 8 plus 3 is 11. So now at this point, you would simply plot those points. So if we do so, we can go over here and we can come up with a rough sketch of our graph. And we'll notice here that we can plot our points. We have the point 0, 3, so that means we're going to go up 3 units on the y-axis. Then we have 1, 5, so over 1 and up 5. 2, 11, so we're going to go over 2 and up 11. And then, of course, we wanted to pick some negative points, which we have -1, which says at -1 we're going to go up 5. And then at -2 we go up 11. And hopefully you probably noticed this, we do end up with a parabola. So where does the graph cross the y-axis? If we look closely here, the graph crosses the y-axis at this point here, and this is what's called the y-intercept. Where the graph crosses the y-axis is the y-intercept. If we look at this, this point is actually 0, 3, and this over here is our y-intercept. Okay, so this is our point 0, 3. Now, does the graph ever cross the x-axis? Well, we notice the graph goes up forever to the left and to the right, so it's never going down here to the x-axis. So in this case, there is no x-intercept. Okay, and I just wanted to point out these two terms, and we'll talk more about these, the y-intercept and the x-intercept, in the next video. Now, some other points you'll notice here. If you notice, when we had 1 is 5, and then we had negative 1 is 5. So when x is 1, y is 5. When x is negative 1, y is still 5. And then also you notice that when we had x is 2, y is 11. When x is a negative 2, y is also 11. And what that tells us here, we're indicating that when the x value is either a positive 2 or negative 2, your y value is still 11. Or when your x value is 1 or negative 1, your y value is still a positive 5. Now, what this is showing here, and I think it's obvious, no matter whether you have an x, and then if you plug in the negative value of that x, you're going to end up with the exact same y value. And when that happens, this is telling us that our graph is symmetric it's symmetric to the y-axis. And what that really means is if you were to take your sheet of paper and fold on the y-axis, the left and right side of your graph here would fall right on top of each other. So that's where we can see with these points where they're opposite. Okay, and again, in the next video we'll talk a little bit more about your intercepts and your symmetry. But since we had this graph already, I wanted to go ahead and point out so you can start thinking about x and y intercepts and the symmetry of your graph. And if it's symmetric to the y-axis, that means the graph will be able to fold kind of a reflection across the y-axis. And the same thing would be true if you're talking about symmetry with the x-axis. All right, if we look at our next example, we have y equals 3/4 x minus 1. And again, we have a table that we want to complete. So we could simply plug in the values, and we could go y equals 3/4 times negative 2 minus 1. And here we would get y equals, well, 3/4 times negative 2, we would multiply and we would have a negative 6/4 minus 1. And at this point we could simplify and we would have negative 6/4 reduces to a negative 3/2 minus 1. And of course we would need a common denominator, so we have negative 3/2 minus 2 over 2. So therefore y equals negative 3/2 minus 2. We would end up with a negative 5/2. Or if you prefer, you could divide this, and this would be equal to a negative 2.5 or negative 2.5. Okay, now I want to point out we could go through all these steps, but I want to look at another way we could complete this table. And this is where I want to look at using your graphing calculator. So if you have your graphing calculator, you want to get that out. Now I'm going to be looking at the TI-84 Plus, and if you have a TI-83, it's going to be very similar. You're going to go to the top left corner here, says y equals, and we're simply going to type in the equation. So we're going to type in 3/4, so that's simply 3 divided by 4. You'll notice here there's no fraction key, so you're just going to simply hit the division key. So that gives you the fraction 3/4. And your variable X button is here at the top left. It has an X and a T and another symbol and an N. So that's your 3/4 X minus 1. Okay. And then if you hit second function, when I say second function, this is the little button in the far left corner with the 2 on it. So you hit second function, and then at the far right top it says table, where the button is graph, but above it says table. So if you hit second function and graph, you're going to access the table. And you'll notice I have values in here. Now you could simply just sit here and hit the delete button so we can delete those out. Now if you have values in there that you cannot get rid of, or if they're automatically put into the table, then you can go to, again, this second function and hit the window key so that we can get to the table setup. Now the table setup allows you to determine whether the calculator is going to pick numbers for you automatically, or if you're going to be able to plug in values yourself. Now if you notice here, if you scroll down using the little arrow keys to the right, so if we scroll down to where it says independent, and basically this is your independent variable, which is our X, and I want to make sure that we have ask highlighted. So that means we can actually type in any X value you want. And then the dependent should be highlighted for auto. The dependent is your Y value. So that way the calculator is going to ask you for the independent, which is the X, and then the calculator is going to give you the dependent, which is the Y value. So simply put the cursor on ask and hit enter, and then ask should be permanently highlighted. Then you can go back to second function and graph. So now at the table you should be able to type in any value that you would like. And now I'm going to go back and enter the values from our table, the -2, 0, 1, 4/3, and 2. So if we type in -2, and make sure you use the negative at the bottom of the screen, do not use your minus key, so the -2, simply hit enter, and the calculator is going to give you the -2.5. And then if we continue along, we can hit 0, enter, -1, and then we could type in 1, enter, we get a -2.5, type in 4/3. Okay, now if you notice here when you type in 4/3, your calculator is going to change that to a decimal, which is 1.3. So that's fine, but when you plug in 4/3, your Y value is 0, and if we type in a +2, we get an answer of 0.5. So from here you could take these points and you can actually plot those to come up with your graph. Now you could also go to your calculator and we could simply hit the graph button, and that would also give us the graph. Now here we wanted to actually complete the table, so we could go back and fill in our points here, where we would have -1, -2.5, 0, and 0.5. So now at this point I'm just going to show you, you can hit the graph button and we will come up with the graph. Now what do each of these little marks here represent? Well, if you go to your window, this window button here, it says X minimum is -10. Well, that tells you the smallest X value on the screen. And if we go down, X max is +10. That tells us the largest X value. And the X scale tells us what we're counting by. So that means each little tick mark is equal to 1. And then the same thing for your Y minimum and Y maximum in your Y scale. Now if yours don't say -10 to 10 for the X and -10 to 10 for the Y, you can simply type that in. This is kind of the standard window you're going to see for your calculator. And to get to this really quickly, for example, you could simply hit this zoom button at the top of your calculator and zoom number 6. You can either hit the number 6 or scroll down to highlight 6 and hit enter. I'm just going to hit the number 6. Zoom standard is going to take your screen and make it where you're going from -10 on the left to -10 to +10 on the right for your X, and then -10 on the bottom to +10 on the Y-axis. So I'm going to take and make a copy of this. So here we have our graph, and I just want to reinforce the way we set the screen up. Here we were going from negative 10 to 10, negative 10 to 10 on the Y. So that's telling you the dimensions of your screen. And remember, it said, what is your scale? And the scale was actually which each of these little marks here represent 1. So each mark here would be representing 1. So for example, here's 1, 2, 3, 4, 5, 6, 7, 8, 9, and then the last one is 10. So that just tells you the dimensions of your screen. Now, if you notice here, we could see that when x is 0, we get a negative 1. Well, when x is 0, we're right here at negative 1. And this point happens to be, once again, our y-intercept. And you will notice that we also have our other point here, which is 4/3 0. Well, 4/3 is really 1 1/3. And if you look, it's just a little bit past 1 here. So we can see it looks like our graph does cross right here at this 4/3, which would be 1 1/3. And because this is where the graph crosses the x-axis, this is the x-intercept. Now, keep in mind, we will talk a little bit more in detail about the x and y-intercept. Now, I do want to show you, if we go back to the calculator, if you wanted to change your screen, you could go to the window, and let's say that we want to kind of zoom in on the graph a little bit. For the x minimum, we could simply type in -5, hit enter, type in 5 and enter, and then go down to y minimum, -5, enter, and y max we could make a +5 and enter. And now when I hit graph, notice we zoom in because your screen is only going from -5 to 5 for your x and -5 to 5 for your y-axis. And this is where we can really see the graph where it crosses the x-axis at the 4/3. So that's a little bit more than 1. So that's your 1 1/3. We can see that it's definitely crossing a little bit more than the value of 1. Now again, you can go in and play around with this window. Maybe we could go out further, or there's actually this zoom button. You can actually hit number 2, which says zoom in, and that means you can take your cursor and you can move your cursor wherever you want to zoom in. So let's say we want to zoom in on this x-intercept, so I'm going to move it close here. Notice here it's about 1.27, and if I hit enter, it's going to zoom in on that point, and we can see here this is very close to the x-intercept. And notice if I move the cursor right to this point, x is equal to 1.3 when y is 0. And again, your calculator is giving you the x-intercept. And again, another button here at the top says trace. We can hit this trace button, and that allows you to then move your cursor along the graph, and it will tell you the x and y coordinate as we go along the graph. Now, keep in mind, all of these points, I want to emphasize this, that any point here, as this cursor moves along the graph and you have all these different x and y values at the bottom, all of these x and y values are solutions to this equation y equals 3/4 x minus 1. And that means you could plug any of those x values in, and that's going to be a solution to the equation. So when we look at making this table, we're only listing a few of the solutions. This graph, which in this case is a straight line, is representing all of the solutions for this equation. And in this case, there's infinite many solutions for this equation 3/4 x minus 1. So if we go back up here to the previous example, when we had this U-shape, this parabola graph, y equals 2x squared plus 3, if we were to pick any point on this graph, then it's going to be a solution to this equation. Alright, so hopefully now you feel a little bit comfortable with your equations, and again we will look at graphing equations a little bit more detailed with these x and y intercepts in the next video.